All right, here we go on your factoring and solving quadratics. Sometimes we need to factor out the GCF. In this case, I see that I can factor out both a 3 and an x. So then you will have left inside 3x minus 2. You can always distribute to check that you've done that properly. And then set each factor equal to 0. So this is a factor, and this is a factor. And then solve. So dividing by 3, x will equal 0. On this side, 3x is going to be 2. So x is 2/3. Okay, and remember, on any of these, you can always graph using your graphing calculator, then find or calculate the intercepts. This one says factor using dots. That's the difference of the squares. So this is a perfect square, and this is a perfect square. So we put down our two sets of parentheses. The square root of this is 2x. The square root of that is 3. So 2x goes in the front of both, 3 goes in the back. In order for the outside and inside to cancel, one of these needs to be a positive and one needs to be a negative. And then you follow the same process of setting each factor equal to 0 to solve. So this would be 2x equals -3, and then x equals -3 over 2. And this one would be 2x equals 3, so x equals a positive 3 over 2. Okay, so you'll want to go ahead and do this checkpoint and have it ready to go for your quiz. We're going to go on down here to the bottom. Factoring a trinomial into two binomials. So if we factor and solve this, start out with your two parentheses. Oops, better fix that. Okay, so the first term comes from the first, so we're going to put an x in each one of these. Factors of 6 would either be 1 and 6 or 2 and 3, and those need to add together to give me a 5 since all of these are positive. So I'm going to use the 2 and the 3. So that, and then your equals 0 out back. So again, set each factor equal to 0. So this one, the solution is x equals -2, and this one is going to be x equals -3. So, and again, you can always put this in a calculator, graph these, and look for your intercepts or your zeros. Factor and solve. This one has an a out front, so remember those are a little harder. A lot of you have been using the x. So these two multiplied together give us 24, and then we want factors of that that are going to add up to -11. So what we can use are a 3 and an 8 can give us an 11. If we make both of those negative, those will multiply to give us the 24. They'll add to give us the -11. So what these two numbers are going to be are our outside and our inside. So fronts of both of these still have to multiply together to give us the 2x squared. So I'm just going to pick a 2x here and a 1x there. So now, since these are supposed to be our outside or our inside, 2 times something can get me to -8, and that would be 2 times a -4. And so now my outside is -8, my inside needs to be -3. So -3 times x would give me that. And then, again, as usual, set each factor equal to 0, and then solve. So that one is x equals 4. This one is going to be x equals 3/2. And then you're going to want to go ahead and do those two checkpoints so that you're ready. But we're going to move on to this side. So factoring completely on this one, we want to look again for a GCF. So we can divide all of these by 2. We can also divide all of these by x. So I'm going to pull the 2x out front, and then I'm left with x squared plus 4x minus 32, and then factor that. So trinomials are going to factor down into two binomials. So factors of 32 are going to be 4 and 8. I want more positives, so no positive there and a negative there. If you FOIL those back together and multiply by that, you'll get back to your original. And then this one has 3 factors, so set each factor equal to 0 and solve. Each factor equals 0. So this one's going to be x equals 0, this one is x equals 4, and this one is x equals -8. If you graph this, put this in your y equals, these are going to have 3x intercepts. And then lastly, this one, or on this one, we're not actually, it doesn't say to factor, it just says simplify. So basically what we're reminding you of here is that x plus 3 squared is x plus 3 times x plus 3. So I'm going to write down the x squared, and then when I FOIL this, first times first is x squared. The outside is 3x, the inside is also 3x, and the last is a 9. Combining like terms, we have 2x squared plus 6x, and then the plus 9 just drops down. And that's all it said to do is simplify that, so that does look better. Over here, as far as finding your zeros or x-intercepts of a graph, remember, that's simply just here and here. So it's x equals -2 and x equals 1. If you wanted to write those as ordered pairs, they would look like that. This one looks like the easiest way is a factor, but again, you can always plug it into your calculator. It's easy to factor when there's not an a out front or when the a is a 1. So factors of 18 that can give me a 7 would be 2 and 9. I'm going to need more negatives, so I'm going to put the negative with the 9 and the positive here. This one is going to be x equals -2. Remember, I'm setting this equal to 0 to get that. And this one is going to be an x equals a positive 9. All right, and this last one, again, we keep setting all of these equal to 0, so this one is not yet. So I am going to add the 20 to get that. And then you will, again, factor that. It's pretty easy to factor. You could put this in your calculator, but it's pretty easy to factor when a is a 1. Factors of 20 that can get me a 9 are 4 and 5. I want those to multiply to give me positive, but add to get negative. So then setting this to 0, that one is going to be a 4, and this one is going to be a 5. And just, I notice this says, what is the solution set? So you're going to see a solution set written in kind of brackets like this as just a list of numbers inside the brackets like that. That's it.